So a chord we cannot extend out from the circle. A secant we can in either direction. Just means we can keep extending it. So secant, which what this is a line, a ray, or a segment that intercepts the circle at 2 points. So I'm intercepting the circle at 2 points, and I'm making 2 different whats when I'm going through the circle. What do we call this right here? What do we call that? Drew, do you remember what we call this? Of a circle? What is this called? Yeah, the arc. So we have one arc and we have a second arc. Raylene, which one is the minor arc? One or two? One. And if I add arc measure of 1 plus the arc measure of 2, what do they add up to? Yep, 360 degrees. That is a nice fact that we should all have memorized at this point. If you don't, come into study hall. We're going to work on it. Okay, that's just intro to a secant line. I'm going to scooch down a little bit. Are we done writing? No, okay, I'll scooch down to like right there. Okay, our theorem, our next theorem, theorem number 10.10. We got a lot, guys. We're almost done with our theorems. We got one more after that, and that's it. Okay, this is the, I'm not even going to call it anything. We're going to draw a circle. Oh, that was a bad circle, but it is what it is. Okay, instead of drawing just one secant line, I'm going to draw 2. One there, and a second one there. So I just drew 2 lines, and they intercept inside the circle. So 2 secants lines that intersect inside. Inside is really important for this. Inside the circle. When they intersect each other, they make how many angles? How many angles are right here right now? 4. Let's label them. 1, 2, 3, and 4. Do you know the relationship between any of these angles? Little recall. Vincent, if I'm looking at angle 1 and angle 3, they have a relationship. What do we call those two angles? 1 and 3. Yeah, vertical angles. So, vertical angles we have now. And what do we know about vertical angles? The what, Vincent? Yeah, they're congruent. They are congruent. So we know that angle 1 is congruent to angle 3. Cool. Lily, when I made these 2 lines, how many arcs did I now make? 4 different arcs. Yep. I'm just going to label 2 of them. I'm going to label the arcs that are opposite 1 and opposite of 3. Those are the 2 arcs that I care about right now. So, and we'll put them in degree measure. We don't need the lengths of these arcs. Good, guys? Yes. So angle 1, this is the theorem. Theorem is now in orange. Theorem says that angle 1 is going to be equal to 1/2 the sum of the first arc and the second arc that they intercept. Now, Aileen, if angle 1 is congruent to angle 3, how can I write this formula for angle 3? Yeah, either way, it's just addition. So yeah, same ones as well. Since those are two vertical angles, they have the same relationship. And they're both congruent to each other. Mm-hmm. Yeah. Okay. That's the whole theorem. I'm not going to put it into words. The theorem is just this. These equations right there. Okay. I would scooch this down. I just ran out of room. But here is an example. Let's just apply this theorem right now. I'm going to draw two secant lines. 1 and 2. I'm going to tell you that this arc right here is going to be, I don't know, 50 degrees. This one down here is going to be 75 degrees. I want you to find what x is in this case. Find x. So Drew, given my equation, what is x in my equation? Just what does it represent? The angle. What angle are we talking about? So that's an arc. Down here, that's an arc. This is an arc. This is an arc. This is an arc. Where are my angles? Where do my lines intersect? Okay, so this is my angle right here, right? Which is kind of like angle 3, yeah. So it's angle x right now. So angle x equals what? 1/2, yep. And then what are the two arcs that it's intercepting? Yeah, plus 75. See what that gives us. Okay, Carson, what did you get when you did 1/2 of 50 plus 70? 62.5. What's my label? Degrees. Perfect. Did we all get that? Yeah, that's fine too. Vincent, can you grab the index cards over here and then pass one out to everybody? I think they should be right under there. Are they right under there? Yeah.
Wait, so how do we get 62?
So what is, we did 70 plus 75 and then divide by 2. Yes, because that's what it's telling us to do. Yes. Okay. Drew, I'm going to scooch you over.
Wait, so, and then we divide it by 2.
Divide by 2, yes. Okay. Okay. Write your name on this. You're going to hand these in to me. This is going to help us. This is independent. This next problem is independent. This is going to improve our quiz scores, okay? Yes. Okay. This is the question. I'm going to give you a circle. This is independent work. we're gonna have two lines. What type of lines are these, Carson? Secant lines. Yep. This arch up here, I'm gonna tell you, is 74 degrees, and this angle right here is gonna be 107 degrees. That was really small. I'm just gonna do this. 107. That was big. 107 degrees. And I'm gonna label these. We'll call this X, Y, W. There should be X down there. So I want you to find the measurement of WX. Mm-hmm. This is independent. Put it on your card and write your name. One theorem for a secant. All having to know. Just write it down. So just apply that theorem to this problem. No, because cosine is the same thing. And I was like, you do. So I don't have a second one for you. Oh, 70. I did the same one. Yeah. Where does 74 go? Oh, yeah, but it wants to. This is oh, that doesn't matter. And these are just the two. We're doing some. So it doesn't matter what. Right now it doesn't matter. Yeah. So try this. This is a come back into place.
So what's one of them?
81 divided by 2 is 40.5.
100.
181 divided by 2, so that's 90.5. Put this in your notes. No. We're gonna do it on one second. So just put this on. but now it's like Lily's 100, so okay, well she's can't okay, she's then. Oh, what about the rest of the class? Maybe I'm thinking about it. Yeah, we just keep doing that, and then we go towards my test. For algebra. We got 1 minute to finish this up. I'm gonna take 1 minute. Is that handwriting that bad? No, it's not. Maybe I did. I would always trust what I write and not what I said.
You want this way?
Thank you. Vincent, you done? Okay. Jody, you done? Well, did you take any notes? You don't have the notes. You don't have to. No, it's what we did today. You didn't write any notes, so you don't have to. I'm focusing. Let's go with an answer. Okay. Our formula states that an angle 1 equals 1/2 of the two angles it intercepts. Two arches it intercepts. Okay, our angle that they gave us is what? 107, which is W. Oh, I didn't even label this. Let's call it T. I don't know. WTX. What are the two angles that it intercepts? Two arcs that it intercepts. Yep, YZ. Vincent, what's the other one? WX. Boom, and that's what we need to find. That's what we need to find. Okay, so Lily told me that this was 107 degrees. It goes 1/2. What arc do we know, Ashley? Yep, 74 equals, oops, not equals, plus the measurement of WX. And that's what we're trying to find right now. So first things first. Drew, what should I do? It's okay, take your time. Do I want to get this all by itself? I have to do something first. I can't do that yet because we're in parentheses. I have to do something else. What's outside parentheses? Yeah, so you don't have to distribute. We can just multiply both sides by 2. Yep, so I get 214 equals now 74 plus the measurement of WX. Camille, what should I do next? Yeah. Subtract by 74. And what did you get when you subtracted 74? Yep, 100. Oops. 140 what? Degrees. Yep. Because we're talking about the measurement, degree measurement of the arc. That's what that M means. So, need in degree measurement. Okay, cool. If you got that right, you just got an extra point back on your quiz. Yes. Do you have any questions about the problem? Or about the theorem? No. No? Sorry, I saw two people shake their heads down. Vincent, you got any questions? No? Drew? Carson? Raylene? Okay. Then we are moving on to our next one. Now those intercepted where? Those two secant lines, they intercepted, yes. Now we're going to intercept outside the circle. So, theorem 10.1. We have two lines. Do you guys like the woody versions or no? Okay, close your eyes. Hands up if you like the woody versions. Hands down. Hands up if you don't like the woody versions. Hands down. Okay, eyes open. We'll do both. Well, we're gonna do both anyway. Well, we were gonna maybe skip the woody version, but okay. 10.1 says the measurement. Or the measure. I keep saying measurement. The measure of an angle formed by two lines that intercept outside the circle that's the important bit, intersect outside the circle, intersect, did I spell it wrong? You can tell me. Okay, yeah, intersect outside the circle is 1/2 the difference. Difference is what operation? Yep, subtraction. The difference of the measurements of the intercepting arcs. So the measurement of the angle formed by two lines is going to be half of the difference of these two arcs. Now, unfortunately, there are 3 ways to draw this picture that we're thinking about right now. So, I'm going to keep that up. We're going to have 3 different cases. Got case 1, case 2, and case 3. Is anyone thinking of a picture in their head right now? Of 2 lines that are intercepting outside of the circle. Does anyone have a picture in their head of this? Nobody? Okay, I want you to draw 2 secant lines meeting outside the circle. That's going to be our first case. I want you to draw it. I want to see how you want to sketch it. Intersecting outside the circle. No longer inside, outside. It's only 90 if it's a tangent. Okay, Raylene, tell me what a secant line. What are its restrictions? Or like, tell me about it. What? It does form an angle. Is it like a certain type of angle? No. But it has to touch the circle how many times? 2. So one line touches it twice. So if I had one, it would look like, ooh, I did it in black. The worst color to do. There we go. Okay. We are going out like that. And I need 2 of them to intercept outside. So they intercept right there. Actually, I'm going to scooch it out a little bit. Boom, boom. That's 2 secant lines. So case 1 is all about 2 secant lines. Okay. Next one. Now we're just talking about 2 lines, right? Meeting outside. Actually, what's another type of line in a circle? Not a secant one, but a different one. A chord. Fortunately, we're not dealing with chords with these. Tell me another one. Yes. Tell me, so a radius stops and ends at another point. Tell me a ray. A ray, yep. What line, when we're talking about circles, is a ray? So it extends out into one direction forever. Another line about a circle, not a chord, not radius, but it can extend out like forever. Yep, a ray. So what is a ray on a circle that only touches it once? If I only touch circle at one point, as such, what did I just draw? Yes, tangent line. So a tangent line, let's do it with the secant line. So there we go. That's another one. So we have 1 tangent plus 1 secant line. And they form an angle right out here, because that's where they intercept. This one is where this one intercepts. So we have 2 secants, 1 tangent, 1 secant, and our next one is going to be 2 tangents. So we meet there, and we meet there. Now we have 2 tangent. Okay, Lily, how many arcs did the first case make? 4. And I want the 2 that are inside that they make right here. So we're going to call this A. I'm going to call this B. A and B. Those are the 2 that we want. Now this is all talking about the difference between those intercepting arcs. So that an angle X equals the difference of the larger one minus the smaller one. So it's always large minus small for arcs. Large arc minus small arc. One half the angle outside. So Camille, for my second case over here, I'm going to label all my arcs. How many arcs do I have right now? 3, right? I have 1, 2, and I have 3. What are their intercepting arcs? Which one are they cutting through and are inside that angle? Number 2. So this is my angle, right? So these are the 2 lines that form the angle. What are the 2 arcs inside of that? Yeah, which one is smaller? 1. So let's change that 1 to an A. So this is A. And our bigger one we call B. And 2 is just outside. We don't care about 2. B. This is the same exact thing. So angle X is 1/2 the bigger one minus the smaller one in degree measures. Okay, Raylene, this is where the X's in case 3. How many arcs do I have in case 3? 2, right? I got this one and I got this one. So let's call this 1 and 2. Which one is smaller? So what should I label that? Yep. And the big one? B. Want B. We want to find X. We want to find that angle. So angle X equals 1/2 the arc in degrees minus the smaller arc in degrees. I was planning on us proving these cases. Like a nice 2-column proof. Takes about 20 minutes to prove it. You guys want to? I think we should just worry on applying these theorems to problems. Okay. Do we have this all written down? Thumbs up? Good? Vincent? Yeah? Cool. Okay. Let's scooch down. Let's do a case 2 problem. So let's do an example. Ooh. We got 15 minutes, right? Do you want to do one together and then some on your own? Okay. Let's do this. We have a circle. I'm doing case 2. So what 2 lines do I need? Yes. So I'm doing a tangent and a secant line. Something like that. There we go. Let's label these. This point right here would be P. This would be S. This one out here would be Q. Oh, I need another one. This one would be R. So I'm going to tell you that the measurement of arc QR is going to be 126 degrees. So right here is 126 degrees. And then I would tell you that PQ is 152 degrees. And I want you to find the measurement of PSQ. So find that angle. x is always going to be the angle that these two lines form. So what angle is it? Wait. So yes, P and Q, but I need P R. We don't have that. You gotta find that. Okay, we're trying to find the measurement of angle PSQ, right? We have a tangent line and a secant line. So what is the rest of this formula would be? This angle equals 1/2 of what two arcs?
Wait, how's that? That's our first step.
Yeah. So we have a tangent line and a secant line. We want to figure out what this angle is right here. So we want to find out what that x is. So Vincent, what are the two arcs that we have to find the difference of? Okay, so measurement of PQ and what other arc? Say it again. P. So I just want an arc. So you don't have to use S. So I went to P. Where do you want to end up? R, right? So it's just PR. PR. So Drew, those are the two angles, two arcs that we need to find. Because one's right there and one is right there. That's what we are intercepting. Which one do we already know? PQ, which is 152. Raylene, how do I find that other arc? What do all the arcs of a circle add up to in degrees? Yeah, so it's 360. So if I add up measurement of PQ plus the measurement of RQ plus the measurement of PR, I would get 360. Yeah, Camille? What was the measurement of PQ, Camille? Yep, and what about RQ? 126, and then I would get my last measurement here. So 360. So when I subtract 152 and 126, what would I get left over if I subtract them from 360? 82? Yep, so 82 equals the measurement of PR. PR. Boom. So I know 82 is up here now. So I'm going to make it go all the way up there into my equation. So Raylene, I need half of 152 minus 82. How do I do that? What should I do first? So I should do what's PEMDAS. Since I have numbers in the parentheses, I should multiply, do what's in the parentheses first. So let's, yeah, subtract. So 152 minus 82. $70. And what is half of 70? $35. And what's my label for this? degrees. Perfect. So we found the angle PSQ equals 35 degrees. Do you have any questions about the problem? Okay. Jude, do you have any questions about the problem? Or are you still writing? Okay. I think we all should draw some facts. All the arc. Thank you, fine. All the arcs in a circle in degree measure add up to what? Yep, add up to 360 degrees. Star that fact. You're going to use it so much in a whole bunch of problems. Okay, I have problems. We would normally do these on the board, but I want you to work on them tonight and just get how far as you possibly can. It goes easy, medium to hard. Okay. So do the easy ones. You can do the, and then just stop to the point where it's simple. Oh, I marked the information that that's a hard one. Focus on the easy ones. The hard one is a mix of multiple theorems. Okay. I want to see some progress on this tomorrow. Okay. I want to see the easy ones done tomorrow. Okay. Cool.